Metals versus nonmetals. Most elements on the periodic table are metals. All metals except the mercury are solids. So mercury is the only element which is liquid in physical form at room temperature. Non-metals could be solids, liquids, or gas state. And all metals are opaque. Most non-metals are transparent. Metals can be shaped by and bent by hammering, and solid non-metals are brittle, so they are breakable, but non-metals can be bent or shaped into by heating them up. Metals are good conductors of heat and electricity, and non-metals are insulators. Metals have a characteristic metallic luster, and non-metals do not have any such feature. So metals have a shiny nature, such as like gold has the shine, iron has the shine, and silver has the shine. So that kind of shiny nature is in metals, and non-metals don't have that kind of nature. Chemical activity. When you look at the periodic table, the active metals are the metals which combine readily to form compounds. Inactive elements are the ones which have little tendency or very less tendency to react chemically. Active elements liberate more heat when they react than the inactive elements. Active elements usually form stable components or compounds. When you look at the periodic table, then all the metals, you can see right here, are more active, and you can see the ones which are here are less active. And these are the non-metals, and these are more active in this nature. Elements which resemble one another in the way they react chemically are said to belong to the same family of elements. So when you look at the periodic table, the elements which have the same type of chemical activity or chemical features, they are classified into one column. And examples are, like you can see this halogens, or they are the salt formers. These are active nonmetals, so they have the tendency to react with other elements, or like in the physical or chemical properties, they resemble one another. So that's why they are kept in one column. Alkali metals are the active metals. They have low melting point. So you can see all these elements which are placed in the same row, same column. They are active metals and they have low melting point. The next type of elements which are in the periodic table are called inert gases. Inert gases are also called the noble gases. They are inactive nonmetals, so they do not react with any chemicals or any elements in the periodic, any other element in the periodic table. So there are 6 of them, and helium, neon, argon, krypton, xenon, and radon. And their atomic numbers are mentioned in here, and they belong to the same column in the periodic table. The periodic law. The Russian chemist Dmitry Mendeleev is the one who formulated the periodic law. It's about 1869, which states that when elements are listed in the order of atomic number, elements with similar physical and chemical properties appear at the regular intervals. So when the periodic table is made, the periodic table is made according to the atomic number of the elements. And when they are placed, so they are placed in columns, and if they belong to the same column, it means they have a similar physical and chemical properties. So in other words, regular intervals, so like when they come under one another, so they have similar physical and chemical chemical properties. That's how they made sure that the periodic table is arranged. This is not like a regular table. It looks a little bit weird shape because they wanted to make sure that if they are under one column, they should have similar physical and chemical properties. Periodic table is a listing of the elements according to their atomic number. I'm repeating again, it's atomic number. That's the based on which the periodic table is listed, and in which a series of rows such that the elements with similar properties fall under the vertical columns. So I have been referring to them as column because we haven't classified that column as a particular name. So still I'm going to go with the same notation of vertical columns. So one is classified in a vertical column. It means they have similar properties. All those elements which belong to that column have similar properties. Now we are coming up with the proper name for the columns and rows. The periodic table arranges chemical families of elements in vertical columns, and those vertical columns are called groups. So if any elements belonging to one particular group, they have similar physical and chemical properties. The horizontal rows of elements of the periodic table are called periods. So the horizontal rows are called periods and the vertical columns are called groups in the periodic table. So it's similar to that. You can see this blue line right here on top. That horizontal row is called period. And the vertical, this blue line right here, you can see that is called the group. So when you look at the periodic table, so most of the elements are metals. Almost like 3/4 of the periodic table is occupied by the metals. As you can see in this picture, all this red or pink, we call it, this is the metals, and a small part right here about close to 1/4 that are non-metals, and only one group are called inert gases. So this is how the periodic table looks like, and periodic table of elements classified into metals, non-metals, and inert gases. Transitional elements, they are placed between the group 2 to group 3, and they include the rare earth metals and actinides. Rare earth metals atomic numbers from 57 to 71, and actinide atomic numbers are from 89 to 105. And those are right under the periodic table into horizontal rows. These are rare earth elements and these are actinides. The electrons in an atom that have the same principal quantum number n occupy the same shell. So if any electron which is with the atomic electrons in an atom that have the same principal quantum number. So you will have principal quantum number, orbital quantum number, and the spin. So you will have a principal quantum number starting from 1, 2, 3, 4, and orbital quantum numbers will start from 0, 1, n minus 1, n minus 2. So whatever the principal quantum number is, so you subtract minus 1 and then you go up till those many. So let's say that if you have 1, you start from 0. And if you have 2, you start from 2 minus 1, which is 1, and up till you go to that number. So that is how the shells are divided into. And the electrons in an atom that have the same orbital quantum number, which is L, occupy the same shell. The larger the value of the L, the more the electrons they can hold in it. So the orbital quantum numbers are associated with S, P, D, F, and S is the subshell which can hold 2 electrons. P is the subshell which can hold 6 electrons. D is the subshell which can hold 10 electrons, and F is the subshell which can hold up to 14 electrons. A cell or subshell that contains its full quota of electrons are said to be closed. it means it is the most stable element. If it has a closed shell, so it has the capacity of certain electrons, and if it has those many electrons, so they are said to be closed and they are very inactive or very stable elements. The electrons in a closed shell or subshell are tightly bound to the atom and not easily removed. The inert gases all have closed subshells and all are chemically inactive. So that is the very reason inert gases are inert, because they have closed shells or subshells. Metal atoms have one or several electrons outside the closed shells or subshells and combine chemically by losing these electrons to non-metals. So metals usually have excess electrons, so they will be looking for another element who want to either take it or share the electron from the metals. So usually non-metals are the one they will be looking for an extra electron, and metals are the one with excess electrons. So that's why metals and non-metals, they react together to make a stable compound. So non-metals, the metal atoms, they always be looking for one or several electrons to achieve the closed shell or subshell, and they combine chemically by taking electrons from metal atoms or by sharing electrons with the non-metals. Across any period of the periodic table, metallic activity decreases from left to right. So when you are going from in a row, if you are looking at, so in a row of periodic table, which is referred as the period, so if you are going from left side to right side, the metallic activity decreases and the non-metallic activity increases from left to right. So when you are looking the non-metals, the non-metallic activity increases from left side to right side. So you can see that if an element is placed in this column right here, let's say, so the most active metal would be right here. So the metallic activity increases from here to here. So any element right here would be less metallic compared to the one which is always at the bottom of the periodic table. And in the similar fashion, if you are going from left to right, then non-metallic activity increases. And if you're going from right to left, then metallic activity increases. Or if you're going from this side to this side, then non-metallic activity decreases. So when you're looking in each column, the most active non-metal would be on top and most inactive non-metal would be at the bottom. So it is just opposite to the metals. So as you can see that, like, if you have an electron of shell 1, then you will have one subshell in that, and that will be S is equals to S subshell, and you will have capacity to have 2 electrons, but hydrogen has 1 electron. So if you see lithium, so it is telling you that atomic number is 2, and then it is telling you that it has 1 subshell with the 2 electrons in it, and so on and so forth. So you can now look at all these elements right here. I mean, lithium is 3 electrons. So in the first subshell, you have 2 electrons. And then once S is filled, then it will go to the P. And in the P subshell, you can put 1 electron. So altogether 3 electrons. So this is how the electrons configuration, electron structure would be. So you can see that hydrogen has 1 shell, has 1 electron, and helium has 1 subshell and 1 shell, and it has 2 electrons is the capacity, and it has complete 2 electrons in it.